All right. Welcome. We're going to get started here in just a minute. Appreciate y'all joining us this morning. Got the countdown timer going. I got my guest Tony Furst here. And I'll be glancing over here, checking the LinkedIn stuff, making sure this is working all right, checking the comments. And thank you all so much for joining us today. It's a absolute beautiful day up here in the mountains. I live right outside of Asheville. And it was in the 50s this morning. And Tony, you're in Fort Myers. I don't think it was 50 degrees there this morning, was it?
No, sir, it was not. Matter of fact, I got up this morning. It was 80 some degrees and 100% relative humidity. It was just a bit thick when I walked outside to put the puppies outside this morning.
Were your glasses fogging? Was it one of those things?
No. Well, I only wear the glasses to read or when I'm on the computer. Most of the time, it's just the contacts. So, no, it wasn't that bad. But the windows in the house are all fogged up on the outside. That tells you how bad it is when the dew point, or the house is about 74 degrees inside, so the dew point is
and the double pane windows are sweating on the outside.
Yes. So that gives you an idea how bad it is outside. It's just a bit thick out there today.
It's a bit soupy. Yeah, I grew up in Florida, so I understand. But
yep.
Welcome everyone who's joining us. We're going to get started here in just a minute. And 5 reasons to choose vertical pumps. It's going to be a real fast 20-minute, jam-packed episode here. If you have any questions, please put them in the comments. We'll hang around after the 20 minutes to address your comments. And we are going to be recording this for our new podcast. So the Engineers HVAC Podcast. And I will put some of this stuff in the comments here so you can go check that out after or during the presentation when you have a second. And also, I'm going to give you a great link to Armstrong's Education and Training Center, which has an amazing volume of topics, all things pumping. So go check those out. Extremely well done, very professional, free content for you. And I'm going to give you a couple other ways to get some of our recordings, which are we bring to you to try and help you be more successful in your business. So we're so glad you're joining us. And I'm grateful to have Tony here with me. Tony's one of the world experts on pumps, especially vertical pumps, since he works for Armstrong, and that's kind of their thing. So he's going to talk a little bit about that. We're going to get started here in just a minute. Again, if you have any questions, please put them in the chat. I'm Tony Mormino with Insight Partners and Tony Furst here with Armstrong. The first time Tony Furst has been on with me live, so we're super excited, and we're going to start doing more of these. And I think we'll do a lot of these quick 20-minute ones and hopefully bring you some information. So, Tony, your first LinkedIn Live. Tony does a tremendous amount of webinars, but I think this is his first time on LinkedIn.
Yeah, this is the first time I've done a LinkedIn Live event. I've done some podcasts for some different people, and of course, any of you that have listened to any of the Armstrong webinars, you've heard my voice and probably seen my face on a lot of different things. And if you've been around ASHRAE or ASPE, or any of the trade organizations, you've probably run across me at some point in time, because I've been in this business way too many years. Hence the gray hair and all that. So in my alternative life, away from work, my nickname is Papa Smurf, because of the beard and age and everything. So
I'm sure the grandkids get a kick out of it. How many grandkids again?
We have 12.
12 grandkids.
Yeah, it's great. It's being a grandparent's one of those great little joys in life that if I could have figured out how to do it first, it would have been even better. Because I could give them back.
I know it. We have three at home, and I love them to death. I'm looking forward to the grandkids one day if we're so lucky. So.
Yep.
Well, we're glad we have Smurf here. We're glad we have the Papa Smurf here. So, all right, we're going to go ahead and get started here in just a second. Thank you all so much for joining us. I'm going to do a little configuring here. You'll see me doing this throughout the thing, and just ignore that. And we'll go ahead and get started here in just a second. So, great. So thank you all so much for joining us. This is going to be recorded and will live here on this channel on LinkedIn. It will also be in our YouTube channel, which you can check out, Insight Partners HVAC TV, which I put in the comments. I put a link to that in the comments just a second ago. You can also listen to this on our new podcast, the Engineers HVAC Podcast, which we launched just a few weeks ago, and we've already had tremendous attention to it. So thank you so much for doing that. We have 4 episodes on there. This will be the 5th. You can check it out. The links to the podcast are in the comments. You can go, you can see it on Spotify, or you can follow us on Apple. So, So also I put in the comments the link to Armstrong's Education and Training Center. Now, if you want to know everything about pumps, please go check that out. You can sign up for their email list. They do 1 webinar a week, and all the recordings live on that site. So it's a tremendous resource, and go look at it. It's very extremely well done. One of the best in the industry, in my opinion. So we'll go to get started. Tony Mormino with Insight Partners, and Insight Partners is an HVAC rep firm. We have this amazing group network of experts around the country that we like to bring to you to hopefully make you more successful in your business. And I have one of those experts here today for the first time, and I'm super excited about that. A little bit about myself, then I'll kick it over to Tony first. So I'm Tony Mormino, and I've been in the HVAC industry for about 25 years now. I graduated with an engineering degree from University of Florida in, 97. And I worked for the first 10 years with Trane. The next 10 years, I worked at a private representation firm, in Jacksonville, Florida, where I was part owner, sales manager, and sales engineer. And that was a lot of fun. And now I've been with Insight Partners for a few years now, and most recently in the role of marketing director, which I have thoroughly enjoyed. And I get to do stuff like this. And I want to personally say thank you for all the people who follow us and watch our stuff online. We're doing a lot of stuff on LinkedIn. We're doing a lot of stuff on YouTube. We're going to start doing a lot more stuff with Armstrong on here. So if you like what you see, please like this and follow us. And I just greatly appreciate all the support for myself personally and for Insight Partners. So kick it over to Tony first. He's going to tell you a little bit about himself. Then we'll just get right into it. And please comment if you have any questions. Thank you.
Hey, Tony. Thanks for inviting me here today. This is really kind of cool. So I've been in this industry for a whole lot of years, over 40. We won't talk about how many, and I won't tell you what year I graduated from college, but I graduated from a little school in Ohio called the University of Dayton. Great little engineering school. Left Dayton, Ohio, went to work for a small little air conditioning company called Trane. Was there for a number of years as an engineer. Basically doing failure analytics, figuring out why things broke and why they didn't work, and then figuring out how to make them work the way they're supposed to. Spent a few years with a major consulting firm, doing a lot of forensic work, looking at designs, working with young engineers, helping them get better. And then a few years ago, came over to work for Armstrong as an application engineer, and then kind of moved my way up to taking over as the head of application engineering for the U.S. So I've got several application engineers that work for me, and I serve not just the HVAC world, but I also manage the application engineering team for plumbing as well as fire suppression. So I cover a pretty broad range of products for Armstrong.
And Chris Kramer says, "Go Flyers."
Oh, there's a fellow Flyer out there. Fantastic. This is great.
Thank you, Chris. And Steve Clankson said, hey, I think he was talking to me, "You're going to have to survive college tuition first." And I was like, yep. Okay.
Yep.
Thanks for that reminder, Steve. Any more comments or questions, please put them in there. It's a lot of fun to engage with you guys. We really appreciate it. So, all right. So we're going to give you 5 reasons why you may want to look at using vertical pumps. Again, we're going to hit you real fast with this. We're not going to take a lot of your time, but please ask questions. Stick around. We'll hang out afterwards. So,
yep.
Tony, tell us what's going on with this stuff.
Okay. So we're going to talk a little bit about why vertical inline pumps make more sense in today's world and in today's market. They've made sense for a lot of reasons for a lot of years, but specifically today, we want to really talk about what's different with vertical inline versus what everybody's used to seeing, which is a horizontal end suction or even a horizontal split case pump. So the first 2 things that we're going to talk about is you don't need an inertia base and you don't need to grout the pump base, because there is no pump base, and you don't need an inertia base because the pump is fully supported by the piping. So there's nothing underneath of it. You don't need a housekeeping pad. You don't need any of that. So there's a huge cost saving advantage to getting rid of all that stuff underneath the pump.
I bet. What is grouting to those
Okay.
who don't know?
So one of the things we have to do, and I'll show you where I'm talking about. So up here, this void space in the base of a base-mounted end suction pump is to be filled with non-shrinking grout. Okay, and grout is a cementitious material. It's not cement, but it's kind of like cement. It's got Portland cement, a few other things in it, and binders and all that, but it doesn't shrink. And so you fill that base up with non-shrinking grout. And the reason you do that is you're adding mass. Okay, and by adding mass, we're adding dead weight to the pump to make it vibrate less, to take out the vibration. You know, one of the things that that we do to take vibration out of a piping system is we add mass to it. We add dead load to it and pull down on it vertically to get it to stiffen up. Well, that's what we're doing with the pump, is we're adding mass to it to absorb any vibrations, to give it more weight. Okay. The other problem is when you have inertia bases, which are in seismic zones and other places where you have vibration sensitivity, is inertia bases take a lot to get them set up correctly and get the springs adjusted properly and get them so that the inertia base isn't actually resting on the concrete floor. I don't know how many times over the years I walk into mechanical rooms and owners are complaining about their pumps are noisy. They can hear the pumps on the floor below, or they can hear it out in the hallway. And you go in and the inertia base is resting on the housekeeping pad because somebody didn't set the spring isolators up correctly. If you go to vertical inline pumps, you'll eliminate all of that issue.
So everything underneath the pump you have circled would be not required for vertical.
Yep. All that stuff underneath there, all that weight, all that space. Okay.
Got it.
So the next thing we want to talk about is we talk about flex connectors. Okay. These wonderful little flex connectors that are up here in the piping that everybody puts in. And those flex connectors are there because we've put all this stuff underneath the pump to isolate the pump from the piping system so that it doesn't transmit noise and vibration. Well, because vertical inline pumps are inherently less prone to vibration because they don't have an overhung load coming off the motor shaft, and I'll show you in the next picture what I'm talking about. When we get rid of that overhung load, now what happens is we get rid of so much of the vibration. Gravity works to our advantage, and we don't have the vibration problems that we have with horizontal end suction pumps or horizontal split case pumps. Right. And so we don't need to have these vibration isolators in the piping on the suction side and on the discharge side of the pump, because we don't need to isolate the pump from the piping because it doesn't vibrate. It doesn't transmit vibration to the piping. So all that goes away.
Nice.
So now we talk about a pump shaft, and this is a nice cutaway of a vertical inline pump. Okay. So we have up here at the top, we have our motor. Okay, and everybody can see the motor, and then we come down and we have a coupling, and this is what's known as a split coupled pump as opposed to a close coupled pump. And there's two different types of vertical inline pumps. Okay, there's a split coupled, which is what you see here, and the close coupled. The difference is the motor is set closer to the impeller, and the motor shaft is directly connected to the impeller. Whereas a split coupled it's two different shafts that are coupled together by a rigid split coupling. So the beauty of this is there's no shaft alignment required. Okay. And I talked about how gravity helps. Well, because gravity is pulling down on this in a straight line, there's no overhung loads. There's nothing cantilevered out the end of the shaft. Now I eliminate a lot of that vibration. That's why these things have such minimal vibration to them. The other advantage is with this is where we have our shaft seal. Okay, we use an outside balanced mechanical seal. And if I take this coupling half off, and there's 4 to 6 bolts there that take the two coupling halves off, now I can come in here, I take the seal cap off, I can lift the seal out of the seal cavity, put the new seal in, put the cap back on, and I'm done changing the shaft seal in less than 30 minutes. Okay. If I have a base mounted end suction pump with a back pull out, I've got to take the coupling apart. I've got to pull the entire, there's a whole bunch of bolts I got to take out to pull the impeller and bearing assembly out. I've got to put it on a bench. I've got to take everything and disassemble everything to rebuild it and put a new shaft seal in, probably new bearings, put it all back together again. Now put the pump back together. I've taken a whole lot of time to do that. With this, I'm in less than 30 minutes. The other thing is, you notice I said no shaft alignment. Because of the fact that we use a C-face motor and that motor stool, all that is machined as a unit. So the shafts line up perfectly. Okay. Does that make sense?
Yeah. So for those who don't know, what is involved in aligning a end suction pump? It ships to the field, they're putting it in. What is involved in the alignment?
Okay. So alignment involves, so you have two different shafts, and you got to get those two shafts in the exact same plane so that they're in both parallel and angular alignment. And so if you can imagine, I've got two shafts here, okay? Mm-hmm. And, so I've got alignment this way, I've got alignment front to back, I've got alignment vertical. So I've got to get all of those lined up perfectly, because if I don't have them lined up perfectly with the coupling that's in between those two faces, there's a spacer in there. And if I have any stress on that, what's happening is I'm putting undue stress on the motor bearings. I'm putting undue stress on the pump bearings. So what happens is, the way you do it is you hook up, and God, I wish I had a laser alignment tool with me. But basically, you hook up two laser pieces, one on each coupling half.
That could be the next live episode.
Yeah, we'll have to do that sometime. We'll have to do a laser alignment demo. But basically, you set the laser alignment tool up on each half of on the pump half and on the driver. Okay, so the driven load and the driver, and what happens is there's a computer that's looking at the difference in the elevations and in the angulars, and it tells you what you have to do to the motor. Okay, what shims you have to put underneath the motor feet, underneath the four motor feet, to get everything to come into alignment. Then you loosen the bolts up and you're putting shims in, and we're talking thousandths of an inch. Okay, so real thin sheet metal shims, stainless steel underneath the motor to get everything to come into alignment.
So it's pretty precise and important.
Yes, and if you don't do an alignment, a couple things are going to happen. One, you'll tear the coupling up. Okay. So that's the first thing. If you're on variable speed, which pretty much every pump that we put in today is variable speed drive, the slower the speed, the worse the misalignment gets. Okay. Centrifugal force tends to mitigate some of the misalignment. The faster you go, well, as you start to slow down, that vibration gets worse. So if you don't have a good alignment, motors run hot. You actually increase the load on the motors because you're putting stress on the motor shaft, which means you're putting stress on the bearings. You can actually drag the motor down far enough that you can actually get the rotor to drag down into the stator inside the motor housing.
That's not a good thing.
No. And so to do all that, it takes time. On average, what I tell people, it's an average of $1,500 per pump to do laser alignment and get it right.
Wow.
Okay.
Gotcha. So you don't have to do that with vertical pumps.
Don't have to do that with vertical inlines at all.
Great.
Okay. So the next thing is we talk about floor space, and end suction pumps take a lot of floor space. So if I look at a pump, 500 GPM, 90 foot ahead, not a huge pump, but not a small pump. Okay. And if I size a typical horizontal split case for those conditions, that pump takes about 66 square foot of floor space. And that includes the pump and the housekeeping and the inertia base and all that stuff that goes underneath of it. Okay. If I look at a vertical mounted HSC, which is basically the same as a horizontal split case pump, but it's just standing on its end. Okay. It's 42 square feet. Still a lot of floor space. But look at what a vertical inline takes. Same size, same capacity, only takes 14.4 square feet of floor space. Okay. And that's for the two piping drops in the pump. So,
nice.
if I look at a horizontal split case or a vertical split case pump where the casing is split vertically instead of horizontally, I'm still looking at a 36 square foot floor space versus my 14.4 square feet. And even a horizontal end suction, which is the smallest of the three base mounted pumps, it's still 28.5 square feet. I'm half that size. I'm half that footprint in space. So there's a significant space savings by going to vertical inlines.
Tony, does that hold true for the larger horsepowers? And what's the biggest horsepower vertical inline pump you can get?
Armstrong makes vertical inlines up to 1,250 horsepower.
That's a big one.
Yes. And all of those pumps are designed to be 100% supported from the piping system. They don't require any additional supports underneath the pump. It's 100% supported by the piping system.
Got it. Okay. So as valuable as floor space is today, why don't we see more vertical inline pumps in the U.S. These days?
Part of the reason is education is getting the architectural and engineering communities educated about the benefits of vertical inline. There's been some people that run around and go, oh, vertical inlines don't last as long. I can show you case after case of vertical inlines that have been in operation for in excess of 30 years, and the only thing they've done is replace the shaft seal. The pumps are still up and running.
Right.
And ASHRAE did a study on equipment longevity, and the only reason ASHRAE has not done anything about vertical inlines and updated their database is because the vertical inlines that were installed 30 plus years ago have yet to be replaced. So that's the only reason ASHRAE hasn't updated their database to say how long they last, because they're still up and running. And
Armstrong's always made end suction, but you're the pioneer in the vertical inline.
Yes, we've been making vertical inlines since the 1970s, since the early 70s.
Are they more popular in other countries than they are in the U.S.?
Yes,
commercial applications.
Extremely popular in Canada. We dominate the market in Canada for vertical inlines, and some of the guys here in the U.S. that tout horizontal end suction pumps in Canada, the only thing they sell is vertical inline.
Awesome. It's good stuff.
Yep. So when we look at floor space, this I love this picture. This really gives you a really, really good understanding and visualization of floor space. Okay. This is a retrofit project, and I don't remember where this one was at, but this concrete housekeeping pad is what the floor space that was taken up by a horizontal split case pump. Okay.
Wow. Big difference.
So they took the horizontal split case pumps out and replaced them with Armstrong vertical inlines. So you can see how much floor space was gained. Now, granted, this is an existing mechanical room, so they really didn't gain leasable or rentable or usable space for tenant stuff, or they didn't gain space for classrooms or education space. But think about it from the maintenance guy's perspective. Now he's got a whole lot more room to work on that pump. He's got, if this mechanical room were redone, those pumps could have been moved over closer to the wall. You'd have gained aisleway space down the middle of the room, possibly room to put another chiller in. There's all kinds of things that could have been done, but because this is a retrofit application, and I love the visual of what happens and the difference between the space of a vertical inline versus the space of a horizontal end suction or a horizontal split case. The other thing that you have to notice, and you notice there's no support underneath the pump. Okay. There's a couple little supports underneath the pipe elbows. And the reason that's there is basically to keep the pump from acting like a swing. Okay. Those are not there to support any of the weight. All the weight is carried from the pipe hangers up above. Those stands are there to keep the pipe from swinging. That's all it's there for.
Not for the weight of the
Not pump. For the weight.
Gotcha.
And then the little stands you see kind of in the middle that are kind of hidden, those are actually for the electrical. Those are actually from the electrician to support the conduit and everything that comes up to pick up the power feed for those drives, because these are actually unit mounted drives on these pumps so that you can barely see the drive right there where my laser pointer's at. That's the drive that's mounted on the pump. So these are integral design envelope pumps with unit mounted drives.
Got it.
So we look at all that. Here's what it really comes down to. Why do we go vertical? Well, there's no base to grout. There's less noise and vibration. There's no shaft alignment required. Huge floor space savings. And you got a lot of flexibility in your piping, in what you do and how you pipe the pump. Okay. You can put it down near the floor like that. On the smaller vertical inlines, up to about 10 horsepower, you could put them up closer to the ceiling and get them completely up out of the way. So you have a lot of different flexibility. Now, if you're going to put a 200 horsepower pump in, you're not going to put it up in the ceiling. You're going to put it down low so you can work on it. But what I'm getting at is you have more flexibility in what you do and how you lay out your mechanical room and where you put the pumps. Okay. And what you do. You're not limited to mounting it on the floor and taking up valuable floor space. Excellent.
So we had 6 minutes of intro and 20 minutes of prezo. So we met our 20-minute promise. So I just want to say, if you have to go, we understand. Thank you so much. We are going to stick around and talk about a few more things, but I just wanted to keep to that promised schedule of 20 minutes to give you the 5 reasons, which it looks like we just got in there underneath it. Great
Perfect.
job, Tony. With very little rehearsal. So I'm proud of you. That's awesome. I do have a couple questions I'm going to go over in the comments. Please give us some questions if you want. I'll go over the ones we have. I have a few questions for Tony. If you have to run because of the timing of this, please follow us, come see us. There's a bunch of links in the comments to Armstrong's full professional library of pump webinars that Tony's done many of them. There's links to our YouTube channel where most of our stuff lives, and our new podcast, the Engineers HVAC Podcast. So go check that out.
And Tony, on another note, if anybody that's listening today wants to have a more in-depth conversation, reach out to you or me, and we'll be more than happy to do that. That's what we're here for, is to help everybody out.
Absolutely. And yeah, if you have a pump application layout you're looking at, an existing one or something you're going to design, hit me up just go to my LinkedIn profile and hit me up in the messenger, and I'll get you with the right person, or I'll get with Tony on the phone or on the computer here, and we'll be glad to help you. Thanks for mentioning that. So Steve Clankson asked a question. Does Verticalc still exist in some form or another?
No, it does not. However, if we have a different tool, it's called the design envelope value articulation, which does talk about the cost savings model between horizontal end suction or horizontal pump in general and going to vertical inline. So if you want some help with that, reach out to Chris Dorsey, who is your regional sales manager for Armstrong, and Chris can help you out with that. If you need some training on that, let me know, and I can get Anish to do some training for you, who's one of my application engineers that works for me.
Awesome. Yeah, thanks. I just sorry, Matt, I didn't notice Matt Burrell answered that question as well. So luckily you answered it the same way Matt did, Tony.
It's good since we work together all the time.
Yeah, that is a good thing. Okay, next. Angela Hernandez says, hey, from Aon. So Aon's in the house. Thank you, Angela. My first experience with Armstrong pumps was through an Aon chiller. Let's see here. What changes? So Tanner Teakin, I believe. I hope I'm saying that right. What changes for the structural engineer? What changes for the structural engineer to hang the pump from above as opposed to putting it on the floor?
Okay.
Great question.
So yes, very good question. So it depends entirely on the size of the pump, but what you've got to do is give the structural engineer the pump weight and how it's going to be hung. And what I've seen most often is it doesn't change the hanger requirements at all. If you look at the building code and the mechanical code, both the IBC and the IMC, and look at what the hanger requirements are, most of the time the hangers are way stronger and way heavier than what they need to be. What I have seen a lot of times done is use isolation hangers or spring hangers on either side of the pump, right ahead of the right ahead of the 90s, making the drops down to the pump. And a lot of times those get changed to spring cans. to be able to take the spring load and any movement that may happen. Spring cans work a little bit better, but those are an easy change. They don't really change the hanger loads a whole lot, but we can get you all the loading for the pumps, both dry and wet weights for the pumps to help you do all that.
Excellent and great question. Thank you so much. Let's see what's next here. I lost my place. I was posting some stuff for you guys in the chat here. The next question was from Steve. Steve Clankson had another question. When we were showing the area calculations, Tony, he wants to know if that included allowance for long radius elbows and suction diffuser and also clearance for service.
That did not include the service clearance, but it assumed suction guide and Flowtrex valve. Okay, so using a suction guide on the suction side of the pump and a Flowtrex in the 90-degree configuration on the discharge side.
Thank you, Tony, and thank you, Steve, for the questions. Steve also added a sixth reason to use vertical pumps: no pump bearings to replace.
Very good point. Very good point. I didn't really.
You want to talk about that for a sec?
Yeah. So because of the fact that we're vertical hung, so that the impeller is hanging vertically off the shaft, all the bearings are in the motor. There's no bearings in the pump, unlike a horizontal end suction or horizontal split case where there are bearings to support that overhung load. So you have to have bearings out there to support that overhung load. And you've either got one or two, depending on the type of pump, the style of pump you have. With a vertical inline, all your bearings are in the motor. So you don't have all that bearing stress load going on at the pump end.
Nice. And I'm posting some stuff in the chat for you guys too. Thank you so much for all your questions, guys. Okay, so next question. Let's see here. Andy Chapman was our last one. Oh no, Steve Clankson mentioned the pump bearings. He also said ease of seal replacement, which would be another reason to go vertical. Yep. I think we did talk about that the seal replacement is less than a 30-minute task to change the seal out on a vertical inline, and that's with a split coupled. Now, if you have close coupled, it's a little bit longer process, but not significantly. The advantage to doing a seal replacement on a split coupled vertical inline is I don't have to touch the motor. I don't have to take the motor off. It stays in place, so I don't have to rig the motor out of there. And that's especially critical when you get above 10 horsepower because the motors start to get heavy. I had an engineer the other day that actually didn't know how much a 50 horsepower motor weighed until I gave him the motor weights. He thought all the weight was in the pump. He thought the motor, never mind. Motors are very, very heavy.
Yes, they are.
A 5-horse motor is heavy for me. So,
yep.
Yeah. Bill Adams said the Prezo was not long enough. Well, thank you. That's way better than hearing it's too long and for us to be quiet. So we appreciate that. Okay. So Chris Kramer, do vertical pumps still need seismic restraints based on the seismic area / criteria? Great question. We were just talking about that before the thing.
Oh man. See, I told you this was going to come up. So I'm going to switch slides on us. So yes, seismic is an issue. Okay. It's an issue with any piece of mechanical equipment. Okay. The biggest issue with vertical inline pumps is the overturning moment. Now, no, the pump's not going to turn over in a seismic event, okay, because it's bolted to the piping and the piping's rigid and it's not actually going to fall over. Okay. Understand, though, that there are overturning moment forces applied to that pump and to the pipe flanges. Okay. And the way we deal with that is we can put stanchions underneath the flanges to spread that torsional load out over the floor. Okay. And several of the noise and vibration and seismic guys make specific torsion or pipe stanchions to go underneath it. They bolt to the pipe, to the flanges, and they bolt to the floor. And basically they spread that load out over a much wider area to eliminate and mitigate the overturning moment forces that happen. Okay. So you can see the formula. This is straight out of the ASHRAE handbook. This isn't anything that I've done. This is out of the 2015 ASHRAE HVAC Applications Handbook, chapter 55. So if you want to go check my math, you're more than welcome to do that. But that's awesome. What it is, and we have to deal with it. It's not hard to deal with. We deal with it all the time.
Great. Thank you, Tony. We were just talking about that before in case that question came up. So thank you, Chris Kramer. Thank you so much for the question. We appreciate that. Bill has a question. Bill Adams, how do you document a pump without a name tag, such as the deadheading and amping and the pressures?
Oh, boy.
I guess if you come across a pump in the field doesn't have a name tag, what do you do?
Well, if you can figure out whose pump it is, if you know the motor horsepower and you know the casing size, then at least it gets us into the ballpark of what pump family it's in. Okay. So I can go look at for like a vertical inline, I can look at a 10 by 10 by 13. So 10 by 10 by 13 is 10-inch flanges in and out. Okay. So 10-inch inlet, 10-inch outlet. The 13 is the casing diameter. Okay. So if I know that and I know the motor horsepower, then I can go pull a family curve and I can know what the range of impeller sizes that I can put in that pump are. Okay. So that will give me an approximation. Once I have a family curve, then I can at least go, okay, I know that here's the different impellers I can put in that pump. I can then take that information, do a deadhead test on the pump, okay, where I'm going to close off the discharge, read my differential pressure, figure out what the no-flow shutoff head is for that pump, plot it against that family curve that I've got, and get an approximate idea of where the impeller's at in that pump. Is it perfect? No. Is it guaranteed? Maybe, maybe not, depending on the age of the pump and the condition of the impeller, the condition of the casing, but it'll get you close. Okay. And
Very good question.
If you got one like that and you're not sure what to do, give me a call. I'll be more than happy to help you out.
Yeah. Give us a holler. We'll figure it out for you. And before we go to the next, we have several more questions. Thank you all so much. Before we go further, how about some likes for Tony? What a great job you're doing, Tony. Thank you so much. What a great resource. So if you can like this video for us, we'd greatly appreciate it. Okay. Chris Amio from Puriflux is asking, how long has the vertical design been around, or has it been around a long time and maybe has become more price competitive because of advantages of manufacturing, et cetera?
The vertical inline style pump has been around since the 70s. And yes, it has become more cost competitive because it is gaining in popularity. And the more popular it becomes, the more people start to realize how good it is compared to end suction pumps, and gets used more. The more we start to produce, of course, the cost gets even more competitive. It's all order of magnitude.
Excellent. Thank you, sir. Andrew Chapman, PE in Atlanta. Okay. Andrew's a brilliant man, so I know this question is just going to blow us away. All right. So do you have any YouTube videos comparing a seal change of a vertical inline versus an end suction pump? And it looks like Matt Burrell already posted a link to that video. So if you're in the chat, if you're in the comments, go down and look for Matt's. Thank you, Matt. Matt needs to be at all these. He's helping us out big time. So
thanks, Matt. Thanks, Matt. I owe you a bourbon the next time we're together, buddy.
Yeah, that's right. That's right. So awesome. So thanks, Andy, for the question. That's a great question. We probably should have had that link ready and played a little of that, but that's a good note for last time. Sarah's asking if the slides will be made available. Just message me, Sarah. I'm sure we could get something to you, maybe just a summary of the 5 points. Armstrong probably has a profile engineering guide on this anyway, so just send it to me. Send me a message.
Tony, what I'll do is I will PDF this, the 6 or 7 slides, whatever it was, and send it to you, and then you're more than welcome to send this out.
Excellent.
As a PDF.
And you can, if you're watching, you can message me, or I will just go ahead and send it out to everybody who attended this event, so everybody will have that on there. So okay, so let's see here. There's some links here to check out our podcast, check out our YouTube channel, go to Armstrong's library of great videos. So okay, so Tanner Teakin has a great question. Can you list any limitations and or disadvantages for using vertical pumps? Good question.
I can't think of any, because I can use a vertical inline every place I use a horizontal split case or horizontal end suction pump. I use them on hot water. I use them on chilled water. I use them on towers. I can use them literally in any application.
Okay. Thank you, Tanner, for the question. And Tanner's asking, this is a great question because this is the question I was going to ask. So what is the install cost comparison between horizontal versus vertical?
On average, vertical inline is about 20 to 25% less expensive to install than a comparable horizontal pump. Now, I'm going to put this out there. It depends entirely on your application criteria. Are you doing, can I do a unit mounted drive versus a drive on the wall? What other things are going into it? If I'm comparing it on new construction, retrofit, it becomes a little bit different because it depends on if I've got to start changing piping around. Okay. So all those things kind of play into that cost difference.
So a total install cost savings overall is the general feel. Okay.
Yeah. New construction, we're typically 20 to 25% less. Not always, but most times.
Great question too. I was going to ask the same thing. So David Schaefer, pros and cons of a vertical pump in a maritime / shipboard environment.
Wow. I've never looked at that specific application.
Well, maybe
I'd be more than happy to look at it. I'd be more than happy to look at it. I've just never looked at it as a specific application.
Right. So I wonder if it's any different than the advantages of
I would imagine
being on a ship.
I would imagine, one of the things that you have to think about on board a ship. I'm thinking the space savings would be a big issue. However, it also depends on what are they using for the drivers. Are they using electric motor drive, or are they doing? I've done some really big jobs where pumps have been steam turbine drive. Steam turbine drive in a vertical inline pump doesn't mesh up real well, just because everything's got to be horizontal for that kind of an application. Because the shafts. So I've not looked at that in a maritime application, but whoever that is, if they want to have a deep dive discussion with me and share more with me, I'm more than happy to look at it.
Yeah, that would be a fun one to look at. So Dave, reach out to me or Tony, and we'll get with you and look at it.
Yep.
Steve Klinkson had some very important information. He said Matt drinks Jaeger. He is a Georgia Tech grad. So you don't have to buy him bourbon. You have to buy him Jaeger, I think. So thank you, Steve. Anyway. So when you do these live, you never know what you're going to get.
Yeah, Steve's giving up all Matt and I's secrets. That's the problem here.
Bill Adams asked if he can get an email. I'm assuming for the slides. Bill, you can email me. I know we've talked before and emailed. I'll be glad to get that with you, or you can message me here. So Dave says, thank you. And you are welcome, Dave. Reach out to me here. If it's easiest to reach out for me on LinkedIn, do that. And I will get you with the right people. And it looks like that is the end of our comments. And I really want to thank everybody, especially my guest, Tony. And I would like to do more of these. Let's set up another one. The quick 20 minutes ones plus Q&A are a lot of fun. Yep. And I think a little more digestible for people as busy as they are today. And for those of you who joined us, thank you, Tyler, or are watching this in the future when it's not live, thank you so much. And also, we're going to put copies of this on our podcast, the Engineers HVAC Podcast. Come check it out. The links are in this chat. And if you're rewatching this, all the links to our content for Insight Partners and for Armstrong are in the chat. Sign up for Armstrong's email list on their education and training site. It's a tremendously valuable tool. They do one live a week currently, and it's all stored there. So if you don't have time to watch it, you can go there and watch it anytime. And you get to see Tony every week if you want. I mean, come on. You're welcome, Andrew. Thank you, Steve. It's just getting a lot of thank yous in the comments here. So
yeah. Well, Tony, thanks for inviting me today. This was fun. This was quick. This was more conversational than a prepared webinar. So this was fun.
I like it. It's a lot of fun, and the LinkedIn Live and YouTube Live platforms are really cool because we get to interact with the guests more, and I think it's a lot more fun for them too. So Thank you, Tony. If you could stick around for a minute, I'll end the stream in just a second. And thank you so much.
All right. Thanks, guys.